Greetings and welcome, friends. This is Mr. Waddy and my buddies in algebra, and we today are looking at this idea of systems of equations, specifically systems of linear equations, although in the future we'll talk about other types of systems where you could, instead of reading the newspaper, you could look at and graph like all sorts of curves and find intersections between them. You could do all sorts of wonderful, wonderful things. So a system of linear equations is a set of two or more linear equations in the same variables. An example is shown below. So instead of one equation, we have two. Sometimes we have a curly brace like so. Question, comment? Yes. A solution of a system of linear equations. Now, guys, I don't know if you remember this. A solution of one equation, Amity, was when the x and y made that equation true. Question, friends, how many values of x and y make this equation true? Infinitely many. This equation represents a line. How many points are on a line? Infinitely many. How many points are on this line? Infinitely many. And as far as a solution of a system, it is going to be any value of x and y that make both equations true at the same time. If it works in one but not the other, that means it is on this line but not that line. I'm looking for points that are on both lines at the same time. So let's start with this idea. How could I check to see if something was a solution? So they're saying, is 2, 5 a solution of the equation? So here's an x1, y1. Let's do a check. So let's plug it in for the first equation. Is 2 plus 5 equal to 7? Yeah, 7 equals 7. True story, true story. Cha-ching. That works. That means that this point would be on that line. Let's check it in the other one. 2 times 2 minus 3 times 5, is that equal to negative 11? Well, let's do a little bit of PEMDAS here. 2 times 2 is 4 minus 15 equals negative 11. You with us? With us? Yeah. Negative 11 equals negative 11. That works. Because it worked in both, that means it is a solution of the system. Okay? So the answer is yes. All right, let's check this value in this system. Okay, so here's a point, and I'm interested in, is this a solution of that system? Hey, those ones are in slope-intercept form. So let's plug in 0 for y. Is that equal to negative 2 times negative 2 minus 4? All right, I plugged in negative 2 for x, 0 for y. Let's PEMDAS. 4 minus 4. Ooh. 0 equals 0. True story. Cha-ching. Graphically speaking, that means that this point is on this line. You guys feeling it? That makes sense? All right, let's plug it in the other one. Is 0 equal to negative 2 plus 4? 0 equal to 2? Uh-oh. It is not a solution of this equation. What does that mean graphically for this point and this line? It only works in the top one. So if this point was on this line, and it was not on this line. Okay? And when I combine those two things and ask, is it a solution of the system? The answer is no. No. That this point was on one of the lines, but not both of the lines. And so if you think about solutions of systems, if a point is on two lines at the same time, visually, what would that look like? What would that point be in relation to both of those lines? That point would be the intersection. All right, the point would be, Devin, the intersection. Okay, that the intersection between two lines, Ethan, you can put that away, is going to be the point in which it is true for both lines at the same time. And so one of the ways I can find a solution of a system is graphically, which is what we'll talk about today. I'll teach you some better skills. I think they're better methods next week. So graph each system in the same coordinate plane, estimate the point of intersection. Estimate is unfortunate. Graphing is not the most accurate or the most effective, but it kind of can give us a pretty good idea. Sometimes it works great, right? And the point of intersection is going to be our x comma y solution, is what that's going to be. So I fortunately have given us some graphs. Let's take a look at example 2 together. Now this one, fortunately, this is like going to be just a massive review of chapter 3 content. So if you need to remember how to do that, this is going to be a great review for you today. Every problem, we're graphing two things, right? Gentlemen, we're talking about math right now. If you have a question, comment, observation, please participate. All right, so here we go. I want to graph these. Let's actually have someone help me out. Who wants to graph equation 1 here? All right, how'd you pick that? Yeah, because 5 is the B. Yeah, so begin at positive 5. Oh, wait, which positive 5? The y-intercept, so I'm going to pick at the one on the y-axis. Okay. Why are you picking -2? Because that is the slope, right? Okay, so down 2 and over 1. And I could repeat that if I want. Right, and I could even go up to backwards 1 if we wanted to find more points. So let's draw that line. And so, yeah, so, I don't know, maybe you haven't graphed lines since chapter 3. We've been writing equations of lines in chapter 4. Right, something like that. So this will be my blue line. You're welcome, by the way, that I made some nice graphs for you, some grids for you to start with. So here's the first one. Let's see. Someone else help me. How could I graph the second equation? I'll call this equation 2. Okay, b equals -1, includes the sign there. So where's that on this graph? Starting at the origin, I go, this is -1 on the x-axis. Here's -1 on the y-axis. So there's my beginning. And then I move by my slope. What's my slope? 4. So that means from here I go up 4 and over 1. Hey, that's interesting. Up 4 and over 1. And I could do it again. Up 4 and over 1. Bam. Something like that. So let's draw this line. Now the points on the blue line are ordered pairs, x's and y's, that make the equation true. All right, the points on the purple line are ordered pairs, x's and y's, that make its equation true. So here's a point, right? This is a point, this looks like 2, 7. That means if I plugged in 2 for x and 7 for y, it would be true. But would it be true if I plugged it in this equation? Because the answer was, the student said, was no, and it wouldn't be a solution of the blue line because it's not on the blue line. Okay? So every point, even the decimals, even the irrational numbers, so here's a point, -1, 7. If I plug these values in to this equation for x and y, it would make this equation true. Would it work in the second equation? No, because this point is not on the purple line. Yet, there is a single point, like a holy grail of all the infinitely many points on this coordinate plane, of all the infinitely many points on the blue line, and the infinitely many points on the purple line, there happens to be a single point that makes both of them true at the same time. What are the coordinates of this point? Over 1 and up 3. This is on both lines simultaneously. So if my solution is 1, 3, I could write it that way. I also could say that the solution is x equals 1 and y equals 3. All right? So instead of a single solution to an equation, I now have, right, 2 points, 2 values, x's and y's, that I am solving for. And finding intersections in systems is kind of also how, right, we could then answer all sorts of word problems of like, what's the breaking even point? Or when does so-and-so catch up to Julio, right? All sorts of things like that. Here, let's do one of these monitoring progress questions. I think I gave you one of these. Let's choose the ugly one. Let's do monitoring progress question 4. You guys have that one? I think so. It's a beautiful thing. All right, there we go. So, one's a little tricky. I'll do the first equation, and then I'll have you guys I'll alley-oop it to you guys to do the next one. So let's see, first equation, b equals 3, right? Y equals mx plus b, that's convenient. So I begin at 3 here on the y-axis. What is my slope? Yep, 1/2. So I'm going to go, how do I move by 1/2? Up 1/2, right? Rise over run, our slope is always rise over run. So up 1/2, up 1/2. So here's some points. I'm going to draw the blue line. Oh, I just accidentally did symmetry. That wouldn't be helpful. Let's have you guys now draw the next line. And we'll see if we can find their intersection. Ooh. I began at the B. All right, so we'll have you guys draw the next line, and then one of you help me out. I'll be around to help you out. You're looking. Now draw those lines. Use you can use the edge of a note card. You could use a little ruler. Okay, let's see. Someone help me out here. What is the B for this? All right. -5 is B. What is the slope here? -3/2. So that's down 3/2, right? Rise over run. Gentlemen? Shh. I got this. You just, yeah. Down 3, when the rise is negative, that means I'll be falling. Over 2, right there. I can do that again. Down 3. Devin, don't distract my students, please. Over 2. Are these going to intersect? They're heading in different directions, but remember, they also head infinitely in the opposite. Are they perpendicular? I don't think they'll be perpendicular. Devin, please. They will intersect. Yeah, is there a case for non-parallel but also not perpendicular? Do you think this is a 90-degree angle? I don't think it is. How could I know if these were perpendicular? They'd have opposite reciprocal slopes. Okay, so guys, the purple line has lots of solutions. Here's a solution. Here's a solution, right? Looks like here's a solution. Where is the common solution between both lines? Like right here? What are the coordinates of this point? Which one is which? -4 and 1 is the solution. That means x is equal to -4 and y is equal to 1. So there is our solution. Your job right now is learning this. I pay you in credit. So let's see. Let's do example 3 together. This will be our last one. So guys, all this requires is us to graph these well. And I mean, and it can be a little bit tricky. Like, you know, you might be like, I don't know, is it, you know, if it didn't land exactly on a nice point, here, don't grind those gears. If it didn't land exactly on a nice point, graphing won't be the most accurate method. And that's why we'll end up having some other ones later. So let's do example 3. You're going to want to put that newspaper away and follow along for this. I don't want you to hurt yourself, so I'm here to help. Yeah, you can turn it into like this awesome dubstep mashup. It'll be great. So, okay, check this out. I'm going to help you guys on the start. You're going to graph it. This is a word problem. I don't know if you could tell based on the words. We're going to start by defining variables. Now listen to this. We can find the variables by looking at you guys remember? The question. All right? The question. The very end of this problem, it says find the price per bundle of shingles, and the price per roll of roofing paper. All right, so my variables, I could say X is the price per bundle of shingles. Both of you guys can be quiet and work. I agree with both of you. So let's see, dollars is what that's in, or I guess dollars per bundle, technically, right? Y will be the price per roll of roofing paper. Roofing paper. Variables. And that's in dollars per roll, I guess. You could think about that. So let's see if we can combine these and write our E. V-E-S-A. Vesa, right? Vesa. Yep. So E is for equations. It says the following. A roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. Okay, so watch this. Let's write it in a color. I kind of wish I didn't use blue already. Are you guys thinking that too? Here we go. Here's my first fact. Devin, inappropriate. 30 times X, also inappropriate. 30 times X is going to be, right, the number of bundles times the price will give us the total money spent on shingles. So 30x and means plus. 4 rolls of roofing paper. So 4 rolls multiplied by the price per roll will equal $1,040. So this equation is all about kind of like how much money they spent for that one purchase. Then it says in a second purchase, all right, the contractor buys 8 bundles of shingles. Jimmy. For $256. Don't grind it. It breaks it. And it looks like he buys, what, 0 roofing paper? Yeah. So what's an equation I could write here? 8 bundles of shingles would be 8 bundles multiplied by how much? Ethan, what are your thoughts? It's going to be the same price. And what is that price? That price is X. So 8X equals, and how much does it cost for 8 bundles of shingles? 256. So guys, these are our 2 equations. The way we're going to solve this is by graphing both of them. Now, yeah, why don't we like their current form? Yeah, if we could get these in y equals mx plus b, that would be cool. Yeah, let's do it. Or, yeah, that doesn't even have a y. So that's going to end up being like a vertical line, I think. But this one we could. Or we could graph using intercepts method. No, I'm working on it. I'm showing my steps. So I'd subtract 30x from both sides. Well, as long as you rearrange it correctly. Yeah. Yeah. If you're, yeah. Divide both sides by 4, everybody by 4. And let's see, so I'm going to get y equals, oh man, 2 goes into both of those. That's the same as negative 15 halves x plus 1040, that's 250 plus 10, 260. Here's one equation. We'll show you. We'll try it. How about this other equation? What could I do to that equation to rewrite it? 8x equals 256. What would I divide both sides by? Yep, to get x by itself. And x is going to equal, I should know that. 256 divided by 8. Man, 32. Ah, well. That's good. That's good stuff. So don't worry, friends. So guys, let's see. So here's my equation 1. Shh, gentlemen, be quiet. What is the y-intercept? This one. And what is the slope? Not really. But we'll graph it. We'll see how it goes. So, all right. Oh, you already counted these? So if this is 50 and then there were some marks here, you figured out that each mark is 10? Thank you. Thank you. Unless I left it as negative 30/4. Let's do that. Let's try that. Negative 30 over 4. Let's do both. So guys, let's check this out. Let me zoom in here. I could go down. Let's see. Actually, I got to know my x scale. What's the x scale counting by? 2s? Yeah, this is 10. So yeah, these are counting by 2s, Ethan. All right. So let's take a look at this. Now, I could try to go down 15. So here's 10, down a half tick mark, and over 2 would land me here. But yeah, someone actually asked, and I like this idea. At first I shot it down, and I was like, wait a minute, they're actually right. I could use the slope negative 30/4. To go down 30, that's going down 1 space, Ethan, 2 spaces, 3 spaces, and over 4 is over 2 tick marks in this direction. So negative 30 over 4, that's way cooler. Let's do that again. Down 30 and over 4. And I could even do it again. Down 3 more boxes. And over 4. I would have gone down to a half box. And that's why graphing, Ethan, I think you would agree, is not the most accurate. Yeah, Devin, you can stay a little late. That'll be good. Here, Pack. Yeah, we're not writing this down either. Don't you worry. I'll help you out after. So let's graph this line. All right, so I want to connect the points furthest away from each other because that's going to be the most helpful. All right, so there's my equation. Actually, it doesn't have arrows on the end because I can't have a negative cost for a bundle of shingles or a roll of roofing paper. All right, this next line is even quicker. Does anyone know how to graph x equals 32? Is that horizontal or vertical? It's vertical. I'm going to find 32 on the x-axis. Are they ever going to intersect? No. Yeah, look at this. So there we go. Now, the solution is the intersection. What? Don't worry about it. Don't worry about it. Where does this intersect? It intersects right here. What do you think x is equal to here? 32. And what's y equal to? It looks like it's up 1.5 boxes. 15, I think, yeah. So that's my solution. What does that represent? So 32, 15. So this is the 32, I agree, is the price per bundle of shingles. So my answer would be, right, shingles are, right, $32. And roofing paper. Yeah, don't pack up. Don't pack up. Is $15. Right? So guys, so I was able to answer this question based on like 2 unknowns, right? I didn't know the price of either. I needed 2 hints to be able to get the price of both. All right, so if I don't know 2 things, I need 2 hints to help me out. Okay, that's the idea of how this works. And I can then, once I find that intersection, how did I know what those represented? I looked back at what my variables were, right? That's what it is. So thank you for watching, internet friends. Have a great day.